Let's get a full screen. All right, so this is the other part to lesson set 16. We spent the last video on graphs, and now we're going to do just some mechanical, some equations, some factory, things like that. More based on skills, and I am going to do them from problem 48, at least backwards until I get into the 30s, and then we can wrap it up because those problems you've done quite a bit in the earlier lesson sets, and you should be able to do them in your sleep. But trick of the trade, you got to look at all the problems, whether you understand them or not. You got to at least look at them and think about them for 20 seconds in order to get those conversations started. And the brain works on the problem, even if you're not thinking that you got anything to add to the discussion. Your brain still works on these problems, a lot of times in your sleep. All right, so let's have at it. Point of inflection for this cubic. So you want minus b over 3a to pop into your head. Minus b minus 18 over 3 times 3 is 9. So it looks like negative 2 is our x value. And now we need to figure out what I get when I throw negative 2 in. Well, that's negative 8 times 3 is minus 24. I better get 3 times this and the opposite when I put in negative 2 here. Oh, 4 times 18, yeah. There's a 3 to 1, a negative 3 to 1 ratio, the quadratic term to the cubic term. That happens every single time at the point of inflection. Now I got minus 14 minus 3 is minus 17. So when you put these together, you always get twice that and change the sign. So 48 minus 17 is what, 31? So if I didn't make a mistake and I got checking help out there, negative 2 gets me 31. But as I'm talking to you, I can very easily make careless errors. I have been, so expect a couple. Hopefully, not many. So we're just starting to get to the point, and I keep forestalling the discussion. Probably will still forestall it until after this next test on Tuesday. But I'll just mechanically say that pi, and you can look at Introduction to the Unit Circle and what is a radian. Those are the videos that are kind of prerequisites to this. So pi is the top half of the circle. I'm going to break it up into 6 parts. Good drawings get good answers. Good drawings get good answers. And I'm going to do 29. That means I've got 12 once around. 12 pi over 6 is once around. 24 pi over 6 is twice around. And 30 pi over 6 is 2.5 times around. So this is where 30 pi over 6 is. 12 pi over 6, 24 pi over 6, and another 6 takes me to 30 pi over 6. Well, I want 29. That's this one. I draw a perpendicular. I can see that I have a 30-degree reference angle, and therefore the hypotenuse is 1, and that is 1/2. Introduction to the unit circle works with a equilateral triangle, 1, 1, 1, cut in half. Means that we used to have all 60-degree angles. Well, this one is still 60 degrees, but now we have a 30. And opposite 30 is a half. And if you do Pythagoras, you get root 3 over 2. There's a crash course. So what did I say it was? Positive 1/2. And we want to get, by the end of the term, to look at that and give an answer in 5 seconds or less. So I didn't like the textbook method. I think students had a lot of trouble with it. But here's the answer to a quadratic. Quadratic set to 0. What was the original equation? Well, you can do the following, and we'll talk about them more in class. I'm just going to do mechanics. X minus 2 equals plus or minus 5i. I'm going to square both sides. X squared minus 4x plus 4 equals 25i squared, which equals negative 25. If I bring it to the other side, I get x squared minus 4x plus 29 equals 0. Let's check it by completing the square. That's a rectangle. I'm going to change it into a square. That's it. That is the same as that box. Plus 29 equals 0. Well, that's 25. On the other side, it's minus 25. I hope you can see the plus minus, where we're headed here, right? Square root of 25 is 5, and the minus sign should go outside, and there's your plus minus 5i, which was in the original problem, right? And then you bring the 2 over, and hopefully you can see where that thought process came from. If we can solve an equation, we should be able to work backwards from the answer. All right, let's get rid of that. All right, what do I see? I don't know what it asked. I think it was piecewise function. So let's look at the graph of x minus 6. Let's look at what's inside. That's a linear function. 6 gets me the root. It's crossing the x-axis at 6, and the altitude of the x-axis is 0. That's another name for the x-axis, is y equals 0. What happens when I slap an absolute value on this? All the negative values become positive, and so this hinges on x equals 6. I have a branch that is going down and a branch that is going up at symmetric rates, so to speak, little poetic license. So what do I see? I see 2 branches, and they hinge. The one less than 6 is going down, right? That linear branch is this side of 6, it's going down, and on the other side, I'm going up. What is this equation? That equation happens to be minus 4 times x minus 6 plus 1. What is this equation on the other side? Positive 4 x minus 6 plus 1. Okay, and that's my new function, written as a piecewise. 2 pieces, Reese pieces. Yes, ET want to go home. Yes, down, up. ln of 12. Well, I asked you to memorize some values. A couple are right here. ln of 2.7, ln of 3, 1.1. Roughly, approximations. So how do I change 12, which happens to be 2 squared times 3, into E notation, approximated E notation? Well, I give a new name to the number 2, e to the 0.7, and that's getting squared, times, I'll put a little dot for times e to the 3, which to get 3 is 1.1. Well, it looks to me like I have 2 times 0.7 plus 1.1 as my answer. 1.4 plus 1.1, it's approximately 2.5. Not only do I have that, but I begin to see the rules of logarithms. I see 2 ln of 2 plus the ln of 3. Wow. And it looks like 0.7 is getting multiplied. So I think I have ln of 2 squared. That's where 4 came from. And I guess showing the 2 there is the same as showing it here. I'm not going to say much more than that because I don't think your brain can process it immediately. So just putting something in your head. And the ln of 3, when do you add exponents? You add exponents when you have a multiplication problem. Right? Am I multiplying here? So I can actually do the following. 2 squared is 4. I can bring the 3 into the parentheses, and that's called a rule of logarithms. Yep, that's enough said. All right, so what do we have here? Well, we've been practicing a little bit, finding coordinates. I've been asking you to find 2 coordinates for this, and I hope you pick a number like 5, because that covers that up. I need 16. I need the parentheses to be 4 or negative 4. To make it 4, I can put a 2 with that 5. To make it negative 4, I can put a negative 6. Let's graph where that is. 5, negative 6. 5, we'll call 5, negative 6 here. We'll call 5, 2 there. All right. Now, I could have also done it with the y values by letting y equal negative 2, and then that's gone. I need the parentheses to be 3. Well, I can see a 2 makes that happen because negative 3 squared is 9. And I can also see an 8. So negative 2 is about here. That's the center. I think that's the center here. And 2, negative 2 is, did I make a mistake? 5, -6. I know what I'm supposed to get. I'm supposed to get an ellipse that's more vertical, where I go up 4 and down 4, because that's the square root of 16. So up 4, down 4. Left and right 3, left and right 3. So let me check what I have. And the center is 5, -2. So the center, I didn't leave myself, but it's 5, -2 is the center. If I go 3 to the right, 8, -2 is correct. If I go 3 to the left, 2, -2 is correct. So 2, -2, I guess is, yeah, I guess. Okay, so what it was optically giving me trouble. But there's your ellipse, and it's a little bit more vertical. And that's something that's a little new for you. But certainly finding these points has been on the last several tests, so you should have followed that part of the discussion. And what would happen if this was a 9, since it's new material? Could I multiply everything by 9? I think so. And if I multiply everything by 9, I hope you see a very familiar equation. Yeah, that's the equation of a circle. Okay, and the distance from the center would have been equidistant, north, south, east, and west. All right, moving along. So what do I see? I see an equation. I'm going to get rid of the fractions by multiplying by 20. There's no reason not to. I know 5 divided into 20 means this is going to be 4 times bigger. Multiplying by 20 and dividing 5 makes that 4 times bigger. It makes that just the same size in the numerator. And it makes this one, 2 into 20, 10 times bigger, 50. And I can see x equals 10. All right, we talked about this the other day. So hopefully not having to show that again, but you can move negative exponents. Remember what 3 to the -2 is. It's 1 over 3 squared. That is now in the denominator. So I can move this into the denominator. I guess I'll do it right here. There's 3 squared. It has moved. So has y to the -5. Okay, I'm ready to do this now. I've got x to the 40th over x squared. I see 38 more factors in the numerator. That takes care of the x's. I got 9 times 6, which is 54. And I've got y to the 6th. And just some mechanical problems that hopefully don't take too long. Number 40 was a bit of a word problem. I don't have it in front of me immediately here, but I think I said something like somebody starts with $75, and 5 years ago they started with $75 and they put it into a savings account, and it doubles every 17 years. Okay, so 5 years ago would have been T minus 2020. And every 17 years is what's happening is a doubling of that $75. And you don't have the word problem in front of you. But that's, an initial amount we start with, what's happening to it, and getting the right time elapsed every 17 years. So 5 years ago, 5 years ago would have been 2020. I thought I was going to see T plus 5, but, it's 2025. I think I can get away with that. So 2020 minus 2020 is 0, and I get 75 times 2 to the 0, and that's the same thing as 75 times 1. So we started with 75, 17 years later, which would have been, of course, 17 years from now. So that's 2037. That gives us 17 divided by 7. That now gives me a 1. And so I'm doubling my money, and I get 150 because I'm doubling. Okay, that's what that was. It was a word problem. X squared equals 40. I guess you can see this. I can do it here. Minus 40 plus minus the square root of 4 times the square root of 10 times I. It'd be nice if you wrote plus or minus 2 root 10I. All right, so x squared looks like plus 40 is just moving x squared up 40. When does it hit I to 0? Well, if you think it does, you're imagining things. Well, it does if you imagine things. I'm not sure how to phrase that. All right, so I'm seeing 5 root 9 root 3 plus, minus 2 root 4 root 3, running out of room, plus 4 root 5. All right, so I'm seeing 5 times 3, 15 root 3. I'm seeing 2 times 2 minus 4 root 3. I'm seeing 8 root 5. If you let root 3 equals x, and you let root 5 equal y, then you're looking at 15x minus 4x plus 8y. I don't think you'd put this with the x's. So what's your answer? 15 minus 4, 11 root 3, because they're like terms, and that's what governs likeness. You can't add a 1/2 and a 1/3 the way that's written. You need to make them both divided by 6. You can't add x squared and x and call it x to the third. You can't do that. These are not the same terms to the same exponent, so you cannot add those. All right? These are radicals. Those are the same. I can count them. That's not the same. I can't count that with this. Okay, so 11 root 3 plus 8 root 5 is that answer. All right, system of equations. Let's do it above here. Let's get rid of this. So I see 2x plus 3y equals -4. All right, let's take a little shortcut. Can you see why I know that slope is -2/3? If you isolate y, you can see that that slope's -2/3. Get y alone, prove it to yourself. So you bring the 3 underneath and change the sign. The other slope, bring the 4 underneath and change, -4 underneath and change the sign. So I have one function that's going down at 2 to 3, one that's going up at 7 to 4. And if I want to find the y-intercepts, let x equal 0. The y-intercept over here is 4/3. That's the y-intercept for that one. And the y-intercept for this one is positive 1/4. All right, so I got a little bit of a look-see here. 4/3, let's call that a little bit more than 1. Down 2 over 3, looks something like that. 1/4 is smaller, and I am going to go over 4 up 7, over 4 up 7, looks like that. I better get a very small x positive and a very small y positive out of this, or I've made a mistake. All right, so I am going to get rid of the y column first and hope I get an integer. So what am I going to multiply by? I'll multiply this one by 4 because that's going to make it positive 12. I'm going to multiply this one by 3 because that's going to make it negative 12. And I don't even have to look at that. I've got 8x equals 16. Being careful here. I've got 21x equals -3. If I add these up, I get 29x equals 13. So x equals 13 over 29, which is a small positive x value. I think I'm right. I usually have been giving you integers, so unfortunately, I made a line through this. But let's go back, and now let's solve for the x's. I'm sorry, for the y's. So I got to get rid of the y's. I'm sorry, I got to get rid of the x's. So I'm going to multiply by -7 to make that -14. I'm going to multiply this by 2 to make that positive 14. I don't have to add those up. So now let's leave that x there, that answer. Let's get our small y value. -7 times 3y minus 21y equals -28. -8y equals -2. Adding these up, -30, -29, y equals -30. Sure looks like my y value is 30 over 29, which is a small positive y value. I think I found that point of intersection. Okay. F of x and g of x are given, but I'm asking g of x. That's maybe the first time you've heard me ask that question. Hope it's not too hard because I know what g of x is. G of x is -x squared plus 5. So I'm going to plug that into the g function. And the g function says put your numbers, put your statements in place of x. So I think I need even more space than that. So let me start here. Put your answers or your inputs, put your inputs in place of x. And so what am I going to plug in there? I'm going to plug -x squared plus 5. Ooh, nasty. Okay, so let's do it out and see what we get. All right, so we're going to square this term with a minus in front of it. And then we're going to add 5. So if I square that, I get positive x to the fourth. If I take this product minus 5x squared, I should get minus 10x squared. And if I square that, I should get 25. I'm going to take the opposite of that. So I've got an answer of minus x to the fourth plus 10x squared minus 25 plus 5 minus 20. Okay, and I can get checked. All right, somebody check that. And maybe Yasser can check that and make sure I didn't make a mistake. Because I don't trust my computations when I'm talking the way I'm talking to you, trying to explain things and work at the same time. I don't have that ability much anymore. So this is maybe the first time you've seen this too. If you don't see a number here, but you see log, then it's meant to be base 10. It's called a common log, and our number system is base 10. So there's a button on the calculator. So if you looked at log of 9, you should get an answer that's a little less than 1, right? Log of 10 is 1 because you're not writing the number 10, but 10 to the 1's 10. So 10 to the what gets you 9, something smaller than 1. You want to know what it is? Go to your calculator and push the log button. All right, so this is a base 10 log. So therefore, 10 to the minus 1, that argument has to equal 10 to the minus 1. Logs are exponents. If I have an exponent on the right side with an equal sign, then it better be an exponent on the right. Logs are the value of exponents, and there's a value. It's an exponent. Exponents go on top of bases. So that's x over 3 equals 1/10. Division by 3 becomes multiplication on the other side. 3/10 is your answer. Number 34. This is a tough question. I wouldn't expect anyone in the room to get this at this stage. But h of x is just another way of saying y. We're going to have to go to old school. How do you find the inverse? You change the x's and the y's. And in this case, y becomes x, and x becomes y. Now, we got to get our y's together. The only way I know how to do that is to move this over and make it multiplication. Because we've got to get a y equals a lone statement. We're after a y equals here. Okay, so now what am I going to do? I'm going to subtract the y. I'm going to multiply this out. I'm going to go x times y minus 3x. And I'm going to bring the y to the other side and make it minus y equals 2. Okay. Now I got my y's together, but let's move the x to the other side. So I got xy minus y equals 3x plus 2. Well, how do I get y alone? I factor it out. X minus 1 equals 3x plus 2. You can still see. All right, so what was the inverse? Getting y alone? 3x plus 2 divided by x minus 1. So y to the negative 1 of x is equal to 3x plus 2 over x minus 1. Now, that's a very different type of problem than we've encountered before when we were doing inverses. Now, what might be a nice number? I'll plug a 4 in. 4 minus 3 is 1. 4 plus 2 is 6. If I put a 4 in here, I better get 6. I don't think I'm gonna. 12 plus 2 is 14 divided by 3. So I made a mistake somewhere. Let's see if we can find it, because I don't want to do this all over again. Y plus 2, y minus 3 equals x. Y minus 3, xy minus 3x, yes. Bring the y over minus y. Okay, factor out a y. Oh, there's my mistake. No, here it is. Xy minus y, bring the 3x to the other side. Factor out a y, x minus 1. Okay, divide by that. And I get 3x plus 2 over x minus 1. Huh, I don't see a problem with what I just did. If I put a 4 in here, 4 minus 3 is 1. 4 plus 2 is 6. If I put a 4 in here, I definitely get 14 divided by 3, and that's not 6. Did I copy anything wrong? No. Y plus 2, yep, that's right. Y minus 3 to the other side. That's correct. I'm going to come back to that. All right, did something stupid. I can't find it, but I'm so far into the problem that I don't want to stop. So I'll figure that out on my own time and then figure out what the heck I'm doing stupid. Stupidly, yes. All right, equation of a line. So I see x plus 8 plus 1, 1, 1. -8 to 3 is a change of 11. And 1, 1, 1 to 99 is 1, 12. Okay, and I'm going down. So that should be the equation of the line through those 2 points. And again, we've done these problems so many times. Just let me know if I make an error. All right, so slope intercept. So we've got to do the multiplication, 3/5 x. I got to multiply that, minus 12/5. I need 11 to be expressed as fifths, plus 55 over 11. I didn't think that through at all, over 5, excuse me. Again, talking, not thinking. Yep, there's my 11. And so what's my final answer? 3/5 x minus 12 from 55 is 43 over 5. That's what you should have got. All right, name 3 coordinates. Well, I can see 4 gets me 11. And I know I'm changing by 5, so 9, 14. And I'm going up by 3, 14, 17. I think everybody's doing pretty well with that now. Number 4, I'm going to multiply by 10. Kind of did a problem like this a little while ago, I think. So I've got minus 4x. 5 goes into 10, so I'm going to double that. 10 times minus 3, minus 30. 10s cancel, I get minus 7x. 10 times 1 is 10. All right, so I'm going to add 7x to this side. I'm going to add 30 to that side. I'm seeing x equals 40 over 3. Let's get rid of that. Okay, we're just evaluating. I've got f of x. 4x minus 3y equals 29. I do not know what I asked. I'm guessing I asked perpendicular through a point. So let's say we want to be perpendicular through AB. Then you would write x minus a plus b. Now I know the original slope is 4/3. I've seen the shortcut. Bring the minus 3 in front of, underneath the 4 and change the sign. And the perpendicular slope is the negative reciprocal, so that's negative 3/4. And I think I can see that immediately. Take the y change, or the multiplier in front of y, and just divide it by the multiplier in front of x. And so therefore, that's my answer here. Minus 3/4 x minus a plus b. And for those of you who have, proven that you could do that by bringing the 3y to the other side and dividing it into 4x, that doesn't affect rate. I hope you can see that our slope, our multiplier, was 4/3, which I listed before. All right, so now we're just doing a little fraction work. We're plugging minus 3/4 into f because that was the question. It's posed over there. So I have 3 times minus 3/4 plus 9, which is how many fourths is 9? 36/4. So that gets me minus 9/4 plus 36/4. That gets me 27/4. Right. All right, I'm sure I'm going to make another mistake or two on the way, but let's keep going. It's just practice. I can make mistakes too. Lots of them, especially if I'm rushing. So the conjugate here is 3 plus 7i. 3 plus 7i. I think mathematicians don't like i's in the denominator for the following reason. 2 divided by I. How do you describe that to someone? I'm not sure. But I divided by 2, I think I could give a decent description of that. Whatever you got, cut it in half. Okay, so let's get the i's out of the denominator and see how it happens. Let's do the numerator first. 9 times 3 is 27. 9 times 7i is 63i. We need more space here. Minus 12i. And minus 28i squared. In the denominator, 3 times 3 is 9. The middle terms are going to cancel. I'm going to get positive 21i minus 21i. And when I multiply minus 7i times 7i, should get minus 49i squared. A lot of people make mistakes. I squared. Now, what did we say I squared was? I squared is -1. So if I multiply a number like 27 by -1, I get -27. If I multiply a number like negative 49 times negative 1, I get positive 49. So that answer becomes 27 plus 28 is 55, I believe. 63 minus 12 is 51. I, all over, 9 plus 49, 58. Hope I didn't make a mistake. All right, so when you get good at these, you can see the center is at minus 5, positive 3, I believe, 25 and 9 and 12 with a radius of 7. Okay, as you keep looking at these problems, keep looking for, whoa, is there a way I could do it? Could I streamline it? So I'm not working so long, so I can get to do my favorite activity, read a book. Yeah, sure, that's your favorite activity. So x squared plus 10x. Whatever x is, x squared plus 10x is 10 units longer. This side is 10 units longer than that side. If I want to make it a square, then I'm going to borrow 5 units from 10. And I'm going to tuck it here. I'm going to take 5 units off, tuck it there, and then I can start getting a square. Of course, I got to make an amendment. There's a slight change to that equation, and it's the following. X plus 5 squared minus 25. Binomial squaring. What do we get when we square x plus 5 squared? We get x squared plus 10x plus 25. So what happens when I bring the minus 25 in? I get rid of that constant that I don't want, and I'm back to the original. Plus y minus 3 squared minus 9 for the same reason equals 12. If I bring the constants to the other side, I get 49. And then I've created a table, a triangle, whose side is x plus 5 and y minus 3, and whose length is 7. And as x gets bigger, in order to maintain 49 constant units of change, as x gets bigger, that square area gets bigger, the corresponding square area has to get smaller, and we get that rotation. We get that rotation, and the center is, where did I write it? Negative 5, 3. And I'm going to go up 7, down 7, to the right 7, and to the left 7, and you can find coordinates pretty easily. All right, so that one's done. Just trying to get some practice here. Can't wait to get back to that board over there and find out what I did that was stupid. But we will find out, or at least I will. All right, thought my reasoning was sound. Doesn't seem like the numbers are saying it's sound. Ugh. 3x squared, but we want the vertex and the y-intercept with a sketch. So I'm just going to sketch it, cup shape up. Minus 12 divided by 6, negative 2. Plugging negative 2 in gets me 12. That better be minus 24. It is. So that's minus 12 minus 5 is minus 17. And it's nice to have the y-intercept. 0 is bigger than negative 2. So it's to the right of that number. And I want, what do I want? Negative 5. So there's your vertex. There's your sketch. Almost done here. Getting there. All right. So name this tune. I see a vertex of 5, negative 2, so negative 5 squared minus 2. And I know from negative 2 to 12, I'm going up 10. And what is the squared change? From 5 to 2 is minus 3. But minus 3 is the side of a square, so the area is 9. And that's what I don't want. I don't want 9 units of change. I want 10. That's that function. Take out what's common. X squared equals 2x squared minus 1. And that's set to 0. So I don't know why I wrote that. X squared, oh, because I was factoring. So x squared times 2x squared minus 1 equals 0. So that's good. So what do I have? X squared could equal 0. So x could equal 0. Yep. I don't have anything on the left side if I let x equal 0. And I could have plus or minus the square root of 1/2. Which I wrote a few times already that may have gone right over your head, but this is the same thing as plus minus root 2 over 2. I'll show again why, but not right now. And that's on your memorization sheet. I hope you know that's 0.71. And because I don't think you know it, I said it again. All right. Minus 7i to the 93 is the same thing. Minus 7i to the 93 is the same thing as saying minus 7 parentheses I squared. 45 takes me to 90. So 46 takes me to 92 times one more I takes me to 93. And I know minus 7, I know I squared is -1. And if I do it 46 times I, I'm going to get 7 times 1 times I. My answer is 7i. And that's another problem that we hope to do 5 seconds or less towards the end of the term. Okay, we're on problem 13, a binomial square. So we got to square the first term. We got to double that product. Minus 56 doubled is minus 112. I, and we got to square the last term, which is 49i squared. And I know what I squared does to 49. It makes it minus 49. So I've got 15 minus 112i. Okay. Yasser, I'm tired. If I make a mistake, please just timestamp it again. Help us out. Squaring this binomial, I square 6x, so that's 36x squared. Double the product, minus 42 becomes minus 84x y to the 9th. And squaring this gets me positive 49 y to the 9th to the y to the 18th. All right, that's that thing squared. Name this tune. I see a square root. I see a square root centered at, or starting at 9, -2. So x minus 9 minus 2. Again, these have been discussed in the earlier lesson sets. Minus 2 to 21 is 23 units of change. And here's the change right here. So what happens to this equation when I drop in a 15? I get the square root of 6, and I don't want it. Square root of 6 minus 2 is not that. But if I get rid of the square root of 6 change, 23 minus 2 is that. Okay, so write 64 minus 27 as a product. These are cubes. So I'm going to start with the cube roots, 4 minus 3. I'm going to build the next parentheses off of these. I'm going to square 4, 16. I am going to take the product, -12. I'm going to make it positive 12. And I'm going to square the last term, 9. So what do I have? I have 1 times 28 plus 9 is 37. I hope 64 minus 27 is 37. I do believe it is. Okay, so we're starting to factor the sum and difference of 2 cubes, so I just did it. Solved. Quadratic, set them to 0, so I'm going to move that equal sign over here, and I'll set it to 0. I got a feeling I can factor this. It's probably a textbook problem. And I got a 1 and a 1, and I want a negative, so I'll put the negative there and the positive there, and I got 2 answers. One is -1/2, and the other one is 1. Factoring. Writing the next sentence as a product. What's the first rule of factoring? Take out what's common. 2 times 2x squared plus 7x minus 4. Can I factor that? I think 4 times 2 is 8, and that's close to 7. So I'm going to do an x, and I'm going to do I got to have a 2x. 2x and an x, and I think I want the 4 over there. That gets me 8. If I make it a positive, that takes 1 away, and I think that should work. All right, x plus 5 times what? Well, let's get our remainder. Let's put -5 in here. That's -125, -525, that's positive 250, no, -250. And -10 minus 3. Ooh, I got a really big negative number here. Okay, let's get it a different way. X plus 5 times what gets us x cubed? Well, I think I need x squared. Now I got 5x squared coming out of this multiplication. I want minus 10x squared. I guess I better go down another 5x squared. Wait a minute, I got positive 5x squared. I want minus 10x squared. I want to go down 15, excuse me. So I got to go down 15. Now I've got minus 15x squared. And that gets me minus 10x squared. Now I got 2x. But right now I have minus 75x. And if I want minus 2x, then I better go up 77. That sure as heck has nothing to do with that. So I have to go up 77. Boy, am I tired. I see, 77 times 5. I haven't done that yet. 350, 385. So how do I get from 385 to negative 3? I've got to go up, I got to go down to negative 3. So I got to go down 388. And that's over x plus 5. So I'm guessing that's minus 388. And I can see that minus 250, minus 350, minus 375, minus, it is. So that checks. Okay, had a momentary lapse there as well. All right, can I keep this going? I hope so. All right, come on, Renee. There. All right, which one should we tackle first? Let's go for number 20 so we can get this out of the way. Give my brain a break. All right, so any one of these parentheses could be 0. So x could equal minus 2x, 9 minus 2x. So what makes it 0? Negative 9. So I think 9/2. Took me a moment. Yep, that's going to work. 3x plus 4, that's easier to see. That's minus 4/3. 199x plus 7. My third answer is negative 7 over 199. And if you're not sure where I get those, keep staring at these until you are. 125 is the square root of 25 times the square root of 5. That's a 5. Y to the 4th is y squared squared. Let's get that all the way over there. Z to the 15th is, let's write this one as z to the 14th times z. All right, so some of these square roots are nice. Square root of 25 is nice. Y squared squared, the square root of that is y squared. Divide 2 into 4. Z to the 14th, z to the 7th times z to the 7th is z to the 14th. Divide 2 into 15. You got a remainder of z, right? You don't get any y remainder. You still got a 5 in there. And that's the process. Going to do the same thing now, but we're going to do it with a cubic, which means the exponents are going to get divided by 3. Exponents are going to get divided by 3, and it's nice if you know the cubes. 8, 27, 64, and 125. Those are the numbers that you most likely work with at the high school level. I can see 64 goes into 128 twice. So the cube root of 64 is 4, and there's a 2 left inside. 3 goes into 15 5 times. 3 goes into 4 once, with a remainder of 1. 3 goes into 5 once, with a remainder of 2. That's a simplified version of this. Let's do a little bingo, bango, bongo. Adding fractions. Bingo, bango, bongo. I'll do bongo right now. 5 times 4. Let's do bingo. 4 times 7x minus 4, 28x minus 16. Bango, 15x minus 10. Now, part of learning math is, if you're not sure what I just did, pause the video and look where I got these numbers and you teach yourself. So what I have here is a subtraction of 10 at the end. I want to make sure I get rid of that properly. So 28 plus 15 is what, 33? 40, yeah, 43. Yep, brain is definitely slowing down. Minus 16 minus 10 is minus 26 divided by 20. All right, that's getting this fraction done quickly and hopefully easily. All right, what is 3? Let's see, what is 5 minus 3 divided by 3 minus 5? Take a moment, pause the video, find out. Let's do the next problem. So I'm going to factor this. That's how you reduce fractions. So I see a difference of 2 squares, 7x plus 5y times 7x minus 5y. And that's being divided by 5y minus 7x. Well, if you did pause the video and reduce that fraction I gave you 2 minutes ago, you'll know that that goes into that minus 1 times. And if I multiply minus 1 times 7x plus 5y, I get minus 7x minus 5y. All right, so now we're over here. I know the square root of x starts at the origin, climbs slowly to the right. 2x minus 1 goes up at a 2-to-1 ratio. So I have one intersection, it's an x value that's not too far from 0. Let's find it. So what do I do with the square root of x? I square it. What do I do with 2x minus 1? I square it. And if you don't square it properly, don't expect the correct answer. I've seen a lot of people miss the middle term. That's a major mistake. Okay, what you're doing over here is your binomial squaring. If you have to write out the 2 parentheses, do so. You get it right. All right, so now set it to 0. And we got 4x squared minus 5x minus 1. So let's see what that is. I think we got to have a 4x and an x to get to 5. And I think this has to be 1. That gets me 4. I got a negative. Do I have a problem here? Oh, it's plus 1. Here, I'm yelling at folks to get it right. I got it wrong. So there we go, plus 1. All right, so talking to you, not thinking. So this is better now because I can have a negative negative. All right, so -1, -1, and that will be -5. So what works? Just x equals 1. 1/4 would have been this fictitious answer over here if we had the lower half of the inverse. So only x equals 1 works in this problem. Can everybody see that? Yes. So that takes care of this one. Square root of 10 could have been written as the square root of 5 times the square root of 2. That's helpful because then I'm multiplying times 2 and the square root of 5. Square root of 10 could have been written, I'll keep it as the square root of 10 because over here I'm multiplying by 5 and the square root of 20 could have been written as the square root of 10 times the square root of 2. So I'll keep that. Now I've got square root of 5 times the square root of 5, which by definition, let's give you one that you can see. The square root of 9 times the square root of 9. What do you get when you do that? Some of you might have to say 3 times 3 is 9. But after you do it once, I hope you can see the square root of 9 times the square root of 9 is 9. So the square root of 5 times the square root of 5 is 5 times 2, 10 root 2. Over here, we have another one. We have another pair. So that's 10, that's times 5, so that's minus 50 root 2. I think I can count root 2's. Of course, I forgot to write 50. You can see my problem here, getting old. So minus 40 root 2. What that should have been. Okay, let's cut to the chase on the absolute value problem. Let's just do the inverse. So I'm going to subtract 9. That's going to get me minus 72. I'm going to divide by -4. That's going to get me 18. I'm going to take the absolute value, which is plus minus 18. And I think my shortcut is as follows. 1 is the center. And I think I'm going to go 18 to the right. And I think I'm going to go 18 to the left. That's what I think I'm seeing when I get the plus minus. Okay, that's telling me how far to the right and left I'm going to go. Then I have to add 2. So that's adding 2. So I've got 2 answers. Positive 18 plus 2, negative 18 plus 2. Plus 1. No. Then I got to divide by 2. So wait a minute. So I'm a little wrong on what I should have done is divided it by 2 so I get 9 units of change. I'm learning something here. All right. So this fooled me. Not going to say that now. So where am I at? I'm at positive 18, so I'm adding 2. So I've got the number 20, and I've got the number negative 16. Now I got to divide by 2. So I got 10, and I've got minus 16 divided by 2 is minus 8. And yes, how many units is that from 1? 9 to the right, 9 to the left. Okay, so I just learned something. If there's a multiplier here, when I get to the plus minus stage, I got to be more careful. Okay. That's how I picked up things, is moments like this. And then going, oh, that's what's going on. All right, so that's good. I've been doing piecewise functions for solving, so I haven't solved this plus minus method in years. I just like solving piecewise and then figuring how far I am from the center. All right, so that's EDX problem now. So inverse operations, take 5 away, you get 1. Divide by 3, you get 1/3. The inverse of e to the is the ln. I've asked you to know that approximation. The ln of 1/3 is approximately -1.1, but leave it that way. And then subtraction of 4 becomes addition of 4. And if you want to see how it works, plug it in. 4 plus ln of 1/3. All right, slightly different problem coming your way now. A little bit of a challenge. Solve for x. Remember what log is? Exponential value. So that 2 is an exponent. Exponent go on top of bases. So my first step, let me write it so people can see where we're at more easily. My first step is to move this operation to the other side. I take the base with it. All right, we got a quadratic. We got x squared minus x minus 2. We set it to 0. We got x minus 2 times x plus 1. And I know I can't use -1. Oh, I can. -1 plus 6, 7. Oh, I can't use it because the base can't be negative. Okay, the base can't. I'm so used to looking at the parentheses. I can put a 2 in, I believe. Oh, made a mistake here, right? Getting tired. So I saw that 2, it was plus 6. Okay, and I just checked my work and I knew I did something stupid there too. So 0 equals x squared minus x minus 6, better. So 0 equals x minus 3, x plus 2. That one I can't use because -2, by definition, this is a positive base, so I can put a 3 in here. Now I can see it. 3 squared is 9 and 3 plus 6 is 9. So my only answer was x equals 3. Thought I'd make some stupid mistakes here as I go along, and I am. Careless, not careless, just tired. All right, so I am going to flip this. I've got 1/9 to the -3/2. All right, I'm going to do the flip. Take the reciprocation. I'm going to take the square root. And then I'm going to cube. Right. All right, let's move Renee. Couple more problems, and we're done. Oh, did I finish everything? Good. Oh, 32 and 33. All right, so those were hard for me to put on the board. So what do we have here for 32 and 33? Let's see if it's worth doing. 32, don't have my glasses on. 32, can I see without glasses? Yeah, sure I can. So 1/16 to the x minus 1. So 1/16 raised to the x minus 1 is equal to 4 to the 3x plus 1. Well, they share the base 4. So I'm going to write 1/16 as 4 to the -2. Now I can multiply that exponent. If I do, I get minus 2x plus 2. Trying to be careful here now. 3x plus 1. I'll bring the -2 to that side. 5x, bring the 1 to this side. So x could equal 1/5. That's a quick practice problem there. And the last one, solve the roots. All right, so I'll just make something up because I don't have a picture here. Can you give me the roots for 2, 7 and a equals 3? The roots. Well, I can see them. I'm measuring from 2. I know I got a square root. I know I got 7/3. And if you think you're hitting 0, you're imagining things. Okay, so still got to get back to this problem. I'll sort that out on my own. Maybe mention on the next video what I wasn't seeing. And hopefully get some resolving that problem. All right, but if I just stare at it, it might take me 30 seconds, a minute. You don't need to watch that. All right. Hope this helps somebody get a little bit stronger with skills and concept.